As early as 1755, the German philosopher Immanuel Kant proposed the hypothesis that the Milky Way is only one of many galaxies. In his book Universal Natural History and Theory of the Heavens, arguing that a structure like the Milky Way would look like a circular nebula viewed from above and like an elliptical if viewed from an angle, he concluded that the observed elliptical nebulae like Andromeda, which could not be explained otherwise at the time, were indeed galaxies similar to the Milky Way. In 1917, Eber Curtis observed a nova within Andromeda. Searching the photographic record, 11 more novae were discovered. Curtis noticed that these novae were, on average, 10 magnitudes fainter than those that occurred elsewhere in the sky. As a result, he was able to come up with a distance estimate of 500,000 light-years. 2 times 1010 astronomical units. Although this estimate is about 5-fold lower than the best estimates now available, it was the first known estimate of the distance to Andromeda that was correct to the order of magnitude i.e. which was correct to within a factor of 10 of current high accuracy estimates, which place the distance around 2.5 million light-years. Curtis became a proponent of the so-called island universes hypothesis, that spiral nebulae were actually independent galaxies. In 1920, the great debate between Harlow Shapley and Curtis took place concerning the nature of the Milky Way, spiral nebulae, and the dimensions of the universe. To support his claim of the Great Andromeda Nebula being, in fact, an external galaxy, Curtis also noted the appearance of dark lanes within Andromeda which resembled the dust clouds in our own galaxy, as well as historical observations of Andromeda Galaxy's significant Doppler shift. In 1922, Ernst Oppach presented a method to estimate the distance of Andromeda using the measured velocities of its stars. His result placed the Andromeda Nebula far outside our galaxy at a distance of about 450 kpc, 1,500 kli. Edwin Hubble settled the debate in 1925 when he identified extragalactic Cepheid variable stars for the first time on astronomical photos of Andromeda. These were made using the 100-inch, 2.5 meters, Hooker telescope, and they enabled the distance of the Great Andromeda Nebula to be determined. His measurement demonstrated conclusively that this feature was not a cluster of stars and gas within our own galaxy, but an entirely separate galaxy located a significant distance from the Milky Way. In 1943, Walter Baade was the first person to resolve stars in the central region of the Andromeda Galaxy. Baade identified 2 distinct populations of stars based on their metallicity, naming the young, high-velocity stars in the disk type 1 and the older, red stars in the bulge type 2. This nomenclature was subsequently adopted for stars within the Milky Way and elsewhere. The existence of 2 distinct populations had been noted earlier by Jan Oort. Baade also discovered that there were 2 types of Cepheid variable stars, which resulted in a doubling of the distance estimate to Andromeda, as well as the remainder of the universe. In 1950, radio emission from the Andromeda Galaxy was detected by Hanbury Brown and Cyril Hazard at Jodrell Bank Observatory. The first radio maps of the galaxy were made in the 1950s by John Baldwin and collaborators at the Cambridge Radio Astronomy Group. The core of the Andromeda Galaxy is called 2C56 in the 2C Radio Astronomy Catalog. In 2009, a technique called microlensing, a phenomenon caused by the deflection of light by a massive object, may have led to the first discovery of a planet in the Andromeda Galaxy. Observations of linearly polarized radio emission with the Westerbork Synthesis Radio Telescope, the Effelsberg 100M Radio Telescope, and the Very Large Array revealed ordered magnetic fields aligned along the 10 kpc ring of gas and star formation. The total magnetic field has a strength of about 0.5 nt, of which 0.3 nt are ordered.